This is section 3.1, extrema on an interval. So extremas are extreme values, so a local maximum or minimum. Local means it's the highest or lowest in the area, and then absolute means overall. So a local max is the highest point in the area, an absolute max is the highest overall. Same thing with minimums. So on a graph, extrema, maximums and minimums will come at like bumps in the curve. So for example, if we have a curve that looks like this, okay, if it goes on forever and ever, realize that there are no absolute maximums and minimums, but we have a local maximum here and a local minimum here. It's where it will change from increasing to decreasing or decreasing to increasing. And the extreme value theorem tells us that if f is continuous on a closed interval a to b, then f has both a minimum and a maximum on the interval. Okay, that's only if it's on a closed interval, including the endpoints. So let's look at this function, x cubed minus 2x squared, on the interval from -1 to 2. So we're finding the extrema. So those are either going to occur at the endpoints or they're going to occur at like bumps in the curve. Well, let's start with our absolute because that's easiest. So we're looking at y values. And I noticed that right here is the lowest point on the entire graph. Okay, so that means it's an absolute minimum. The absolute minimum itself is -3, but it occurs at -1. If you just gave me the point -1, -3, that is also fine. Now let's look for an absolute maximum. So what's the highest point it goes? Well, it looks like it's tied between here and here. So our absolute maximum is 0 because the y value is 0. It occurs at 2 places, which is at 0 and 2. Let's look for local minimum. So is there a lowest point in its area? Well, it looks like somewhere around right here. So we have a local minimum of about, I would say, -1.2. Okay, that's probably occurring at about, I don't know, 1.35-ish. I more care about the y value anyway. So that's our local minimum. And then if we look here, this is also technically a local maximum because in its area it's the highest. So I'm also going to say a local maximum of 0. If these are tied and you don't write the local, that's also okay. Critical numbers are numbers where f is not differentiable or the derivative is equal to 0. So if f has a relative minimum or a relative maximum at x equals c, then x is a critical number. So when we look and we think about a function, so I'm going to draw something like this. We know that there's going to be a maximum here and a minimum here. Well, if we look, the slope at both of those points is 0. So that's where that f prime of c equals 0 comes into play. It also happens where it's not differentiable, but we're going to focus more on the derivative being equal to 0. So finding extrema on a closed interval, so when we did it earlier, we did it with a graph. Now if we don't have a graph, we can do it algebraically. So find the critical numbers of f between a and b. So find the derivative, set it equal to 0, and find the values that are in between a and b. Evaluate f at the critical point. So that's saying like what is the y value at that critical point. Then we're going to evaluate f at each endpoint. So what's the y value of each endpoint? And then we're going to pick which one's maximum, which one's minimum. So I'm going to look at this first example here. Find the extrema of f of x equals 3 to the x to the 4th minus 4x cubed on the interval -1 to 2. So my first step is going to be finding the derivative. So the derivative here is 12x cubed minus 12x squared. I want to find where that derivative is equal to 0. So I'm going to set it equal to 0 and solve. So I'm going to factor. I'm going to take out a 12x squared from both of them, and that leaves me with x minus 1. So that we take each part, set it equal to 0. So our critical points occur at 0 and at 1. Now let's find f of 0 and f of 1. So if I plug in 0 for x and the original, I'm just going to get 0. And if I plug in 1, I get 3 minus 4, which is negative 1. Now we have to look at the endpoints. So let's find f of negative 1. So 3 times negative 1 to the 4th is just 3. And then negative 1 cubed is negative 1. So 3 plus 4 gives us 7. And f of 2, we're going to end up getting 16. So now what we're going to do is we're going to look at these 4 numbers, okay, at our extreme value, or at our critical points and at our endpoints, and we're going to say which one's the biggest, which one's the smallest. We can see, obviously, that 16 is the largest and negative 1 is the smallest. So 16 is our absolute maximum, and negative 1 is our absolute minimum.